today's panel discussion, the increasing use of AI in MES systems. Definitely there is an increasing role of AI within the factory space, and this panel is going to discuss some of these challenges. I'm delighted to be joined by Ivan Aduna from Co-Young Technology on the end.
Thank you.
And Ryan Gamble, our keynote speaker this morning at SMTAI from a company called IntraRatio.
Thanks so much.
All right, so welcome, gentlemen. Nice to see you here. So let's get started with the first question, which is how useful is AI in creating the digital thread throughout processes within the factory? And I'll give that to you first of all, Ivan.
Sure. Again, thank you very much for the invitation, Trevor. This is actually a wonderful panel. So, just to get started, right, with the AI conversation, the conversation that nobody wants to have, but is very important. Really, I think, AI will play a very key role in the future integration of, smart factory, the future evolutions of industry, either 4.0, 5.0 as we go beyond, the limit. And for me, it's going to be very important that they understand how these AI models are going to be integrated into the factory. Because, AI, a lot of people think about it as magic, right? It's not magic for sure. So it's something that you can leverage on in order to improve your processes. Because at the very end, all the companies are looking to reduce cost. So without motive, now they can understand how they can actually use these tools, such as AI, in order to improve their processes, reduce weight, and ultimately have, a better efficiency, better prices to offer to their corresponding customers.
Right. Okay. So I think to set the stage, Ivan, on the topic of AI, I mean, the way it sits at the moment, we're really at the stage of machine learning and big data, really. We're not really at artificial intelligence, which is what AI stands for.
Right.
So the machines are not thinking for themselves, but they're really accessing massive amounts of data, essentially. Would you agree with that, Ryan?
Yeah, definitely. Yeah, so that brings up interesting concepts of like what is the supervisor, what autonomy do the machines have if they're running their own little independent AI-based processes, how complex they are, right? If it's machine learning, or it really truly is like, some kind of more decision type tree analysis it's kind of doing based on variables coming in. Yeah, that definitely opens up a lot of deep consideration has to be done for life limit property in that, what are the guard bands? And I think to a certain extent, my thoughts would fall towards you really need a supervisory system, that really sort of has the checks and balances on it. But you can definitely get to a model where each machine is independently making its own decisions, which they are today, by the way, but they're very, it's conditional, if then else.
Right.
Right. But yeah, those are the first thoughts I have based on that.
So when you say a supervisory body, I mean that's going to have to be done. How is that going to be done? Is it going to be done at a country level, a regional level, global level? I mean, who's going to police it?
Yeah, luckily I'll just say for us in manufacturing, very deterministic. This is not like the case where Florida used AI to profile who's going to be a criminal, and that thing ran amok, right? Because the bias was already embedded in it. So luckily we don't deal with those kind of sensitivities. Honestly, I think it's going to be in an industry level. I think where government comes in, it's like, okay, you look at the wave of industrialization in the turn of the century. It's really just to make sure that people, life limit property are taken care of, and that it's not open for abuse. So I think it's really just going to be at the industry level, and then there'll be this higher order view, from government, maybe certain regulations. But again, I don't think manufacturing is going to be in the same level as where we see AI being applied. Again, the police example, where it actually has a social context and huge ramifications.
Right.
But
yeah, and I actually agree with Ryan in a way that, yes, supervisors can be, either whole countries, can be, politics. But at the very end, I think supervising, on a real world is going to be how do you extract this information to create your AI models, right? So someone supervising, because data, won't be perfect. that's one of the major things that we don't consider as we go and create these AI models.
Right.
That our environments are not perfect. There's always data that has to be discriminated or filtered in order to get a decent model for these kind of software or pieces of software.
Right.
So now you gotta have something in place in order to get the right parameters or the input parameters in order to get the desired output.
Right.
And
right.
supervising that process, supervising that model is going to be one of the key elements in order to get the desired output, which is really what all these companies are intended to do, right?
Okay.
They want a desired output, not necessarily something in place in order to completely change the environment.
Okay. Well, that kind of nicely circles back to my original question, which was about the digital twin situation. I mean, digital twins being used for modeling basically designs, the design element part of the process. But going forward, it's anticipated that we're going to be using digital twin to model every section of the manufacturing process, and that's going to then be connected by a digital thread to connect these different digital twin models. Is that how you see things developing?
Absolutely. That's actually absolutely right. Because at the very end, it is just a model, right? So you're creating a digital twin of different pieces of processes, whether it's from the inspection perspective, whether it's SPI and printer, whether it's AOI with pick and place, or else creating a whole digital model of going above into your different systems, right? Whether it's MES system, ERP systems, so creating a whole ecosystem and being able to simulate that on a real environment in order to get the really being able to accomplish a full automated and real-time information to get the decisions that you want to do for the entire production line. So that's going to be extremely important as we move forward.
Right, Ryan. I mean, do you see, from your company's point of view, do you see a future, working with digital twins and folding them into what your MES systems are doing?
Yeah, absolutely. Interesting enough, it goes back to about 2001, 2002. I came out of the semiconductor industry, and that's what we were trying to do already, taking the manufacturing data and feed that right back into design. I'd always have design simulation output out of Mentor Graphics and whatnot. Right, but it was always a flat file or maybe a small database. It didn't connect to manufacturing. They're very siloed, and that's a really powerful thing. And so companies are already doing that. As far as the play for AI within that, as far as Ivan was saying, they are very well-defined models for the amount of process data you're collecting from each node in the manufacturing process. I think the AI part plays into that in terms of it performance tuning the machine for that manufacturability, right? So you basically design for manufacturing is now becoming embedded in the manufacturing line. So I think that's really exciting. So yeah, using AI to just quickly close that loop, that opens up the aspect of like, well, what's going to happen to product engineer, which was my job, right? So basically wiping out more than half my job I was doing at the time. But honestly, I would have been happy if you took half my job away because there were so many other creative things I wanted to work on than grind through data. So I think there's a real value in that, creating that digital twin by leveraging AI where it automatically improves the process, it feeds out the parameters. At the end of the day, you're going to need a human still to connect to that, look at that data and sort of give it the checkbox, because quantitatively how we think is really interconnected.
Right.
So I say if you can replicate our brain into some supervisory system, then you're okay. But I think still we're going to be very much involved as engineers, but it'll free us up, and to do a lot more value add things and not so much grunt work. Yeah,
it's going to be a long time before we're at that level where AI can think it contextually like that, or at the speed of thought, because we think very quickly as well, which is another.
Yeah, and I think we're going to be working towards improving, as Ryan mentioned, and not towards fixing, right, all the time.
Right.
So that's going to be the role change that a lot of engineers will play.
Yeah, I mean, design for manufacturing has been a goal in this industry for so many years, and we've always failed because the information was going one way and it just wasn't looping back to the designer, and the same mistakes were getting made. And, but with digital twin and with modeling, that information is getting back, and so you're getting fewer turns before things get into production, which is much better. There is I was at a conference recently where it was a presentation on a system called Siri, which is a benchmarking system for automation and AI within the factory, and it basically charted how far along the automation path you were, and it came out with a score at the end of it. Do you think that's a useful way forward for companies that are looking, or OEMs even, that are looking to sort of put out jobs to companies that are involving automation and AI?
Well, yeah, it's straight up honest answer. I think it's fantastic because it really makes it hyper competitive. The market, there'll be that but it can create a lot of disruption. We just have to be mindful of the smaller, mid-sized companies that can't build that infrastructure in quickly to basically meet a need. They may have existing lines that are space, military, defense, and then when they get graded on that, they may lose that. So it's sort of like finding the balance where you can incentivize them to become more digitized, so they have a good fighting chance. Because digitization will be a disruptor. I mean, I've seen some of my customers literally grow 4x in a couple of years, just as soon as they go digitized, just how fast they move.
Yeah.
So, but I think overall that is a great way to save on just a lot of time lost trying to connect to the right companies to do your end product and to kind of close a loop. I think that really helps, especially having served as an engineer 20, 25 years, again, product engineer, working between design and manufacturing, being on this side of the ocean and not having any visibility to that on the other side. That feedback loop can really help move quickly.
Yeah.
Final comment on that is just the amount of integration of products today and the requirement, how often they're changing the different versions to support that.
Yeah.
I think that can really help solve that problem where you're just bottlenecked because you don't know if your next version of product can be produced in the existing factory you're using. Right. Without going there, long slog of meetings, things like that. Now you have data to give you that.
And you have a benchmark that everybody's using that you can measure against as well.
Yeah. So I think that's a very powerful tool. But yeah, we just have to be careful about make sure it's used democratically.
Well, yeah, I mean, it is. I mean, I think the presentation I saw was actually being presented by the World Economic Forum. So I mean, it was at a very high level.
Okay, brilliant. Yeah.
Mm-hmm. Yeah. So anyway, but you touched on companies and digitization and really coming forward, but you don't want to digitize for the sake of it. When you look at each process that you're going to automate and digitize, you've got to first of all consider certain steps. I mean, for example, the business value in making that change. What sort of things do you think companies should look at when they're looking to sort of build in automation and digitization?
So of course, there's plenty variables in to put in place in order to just think about the idea of implementing these kind of tools, right? You cannot just go ahead and try to fix everything and try to implement something as big as this, right? So of course different companies are completely different. If you go out there and you go to a manufacturer floor, every single company has a very, very different needs. And Brian will agree with me, especially on the MES integration side. Every single company is completely different. Yeah. So these variables, I think, are going to be the challenge to really put something in place that works for that particular environment. So, just to put out there some specific examples, just the fact that different brands and not every single brand communicate as easy or as smoothly as you will guess. Even though they have information available, even though they have the best process, we have isolated piles of data that they're not interconnecting between the systems. Right. So for me, one of the biggest challenges that are going to be, it's going to be a big conversation with AI, is going to be how do we connect that data? How do we close those gaps or do these closed loops between the systems in order to get the information that you're looking for.
Right.
So,
well, I mean, if you look at the Cisco mantra for collecting data, they say collect everything. You know.
Ooh, yeah, that can be very expensive.
It can be
and
expensive.
dangerous.
exactly.
Right.
Yes.
But then you end up with what they call a data lake. You know, where it just sits there. You don't do anything with it until maybe 5 years later you think, I need to fix this process, and you can then access that information.
Yeah, now you drown in it. You're trying to find how to get context out of it. Yeah, and all the history is sort of lost because it was collected so far back.
Right,
Yeah,
right.
It's an interesting challenge, yeah.
It is an interesting challenge, yeah. So you obviously don't prescribe to that.
I absolutely do not. I subscribe to hyper-contextualization. You know, it's very straightforward. As Ivan was saying, these parameters are very well defined. You know, we're dealing with what batch was loaded, what settings, what was the speed, conveyor, which stepper motor, how many cycles did it do, you know, squeegee strokes. All these things, they're all there. The data's there. It's very deterministic. It's already contextualized for you. Now, when you put it into the so-called data lake system, you know, forget lake, I would just go hyperstructure. You know, today I think we kind of have to move past because the expenses of just collecting the data and throwing it in there. That works for web crawling. That's great. For me personally, it doesn't work for manufacturing. Unless you want to spend millions of dollars to have an army of consultants land on you, sift through it, and try and figure out how they're going to get the reporting. You know, just contextualize right up front. And yeah, go for everything that's available on the machine. But I think every piece of data today, at every process step, it's very clear what its meaning is. It's very clear what it was captured for. It can be already contextualized. You contextualize at the point that you receive it. Now you can really drive machine learning and AI at the point of receipt, right? Now it's tagged with features. You know, the typical term in AI. You know, what features am I modeling on that? And you can run it supervised, unsupervised. So, yeah, that's my little technical take on that. And I've seen it very effective, extremely effective, especially DFM. Closing the loop of the design simulation. That's fully contextualized. When you connect to your design simulation data, you can now map the two very clearly. You understand what it is.
Yeah. No, I agree. So
Thank you.
I'm going to come on to another slightly controversial subject here, which is looking ahead. The EU has put out a forward-looking statement for the development of Industry 5.0. Obviously, Industry 5.0 is going to be built around the AI revolution, and I'm going to read this out just to make sure I get it right. But it says that they claim that Industry 5.0 should be placing the well-being of the worker at the center, using technology to provide prosperity beyond jobs and growth, while respecting the production limits of the planet. Do you agree with that?
I do agree, but in a way that, you know, at the very end, just like internet, right? At the beginning, people were afraid of, you know, what this could do for people or in general for jobs. But I think that's really what it's going to create is just an environment of tools that we will be able to leverage in order to improve all these things that we know that, you know, can be repetitive and we're not really good at it. But, you know, there are tools that can help us close that gap between, you know, our intelligence, or as we know or understand the process, and what a tool can do for us to, you know, close that gap between the repetitive tasks. So, as you know, artificial intelligence, of course, is going to get smarter and smarter as, you know, they continue to develop it. So, I think it's going to be important to have someone, of course, to be in the middle of the process in order to help, you know, create the necessary environmental variables and the ambient to really improve the way that we're using our machines or equipment. Because all the equipment, you know, they're creating gigabytes of data, terabytes of data. But as of now, we don't know how to use them. We just know we have a big pile of data, we have big data, but we don't have meaningful data.
Right.
So I think that's going to be the important role about AI, creating the meaningful data in order for us to better understand those processes.
Right. I know that heavy data crunching is going to get done up in the MES system, basically. So down at your end, on the line level, you're capturing it, you're measuring it, but a lot of that heavy data crunching has to go up to the MES level and then come back down. Is that how you see it?
Yeah, but it's sort of like a divide and conquer scenario too. Each. So I absolutely see that, and then, but what you have is the MES is really more process, ensuring process is followed. You have rules you've set. At a simple term, and just the expense of not trying to make it sound too simple, but you issue a job or you've scheduled something, and you say, I want to run this build, and we have to set up with these recipes and these process parameters, these settings. It's going to go through these steps. And there's a manual process here. Okay, and how we collect the data, okay, map it, go, and they launch the product. So the MES is really about tracking what you're using, making sure you're following the initial baseline rules. Now the machine itself can be quite independent, and I'm a big proponent of this. I think we need to let the machine vendors really own that part, if they're able to and they want to. Ko-Young, very formidable, right? Software side. Software is critical now, equal with the hardware now. So you tune your machine, those process parameters. I think it needs to share that data back to the MES to hold the knowledge of what was the most optimum. So it's really that part. Now, as far as applying the AI to optimize overall factory efficiency, all that, that's another layer. That is part of the MES, but in a way, the MES is serving this more complex reporting that's sitting there.
Yeah.
And so we kind of separated. And before I go, I wanted to come back to the EU thing a little bit, if we're good for that.
Okay.
Okay. I think it's actually, I feel it's fairly brilliant in terms of kind of injecting that sort of idea, Industry 5.0, really focusing on the human side. Without getting into politics or anything, I believe we have actually mortgaged a bit of our future for our kids. I look at my young nieces, 22 and 18, working, into industry now, and they are huge environmental proponents because they see it. I see the environmental impacts where I live, all that. What I also see is the amount of trash, the amount of waste. There's just such low levels of recycling. Yeah. You can't fix these complex electronics. I think that's where it's really powerful. We start focusing on AI to optimize manufacturing process and supply chain in order to create feedback loops of reuse, recycling, so that we're conserving energy, we're reusing so much more, and I think that is so much powerful. And at the end of the day, for the investors out there, that is a lot of money to be made and saved.
And that is the future. That's definitely the future of the industry. I mean, Apple started doing it with this latest iPhone 15. There's a lot of recycled parts in there, and I think that is the future. Anyway, guys, it's been a great debate. We're going to keep talking about it for a long time, but we're running right out of time here, I'm afraid. So I want to thank you, Ivan Ajuna from Ko-Young, and of course, Ryan Gamble from Intra-Ratio. Thank you, guys.
Thank you so much.